but we will get some software later.
Sir,
Okay, so another question. Sorry.
sir, someone is in the waiting room. Naja.
Yeah, I don't see her. Yeah, I'm kind of keeping an eye on the waiting room if I see them, but could you tell her that I can't see her? Maybe she's in already. Yeah, so yeah, Nadja is in. Yeah, she's in now. So she was in the waiting room, but she's in now. All right, let me share the screen with you. Okay, and somebody's in the chat. Let me just get that. Um, I thought I was sharing that screen. Yeah. And there's Shad in the chat. What was in the chat? Somebody was saying something. No, I don't know. Anyways, come back, chat. Just saying I'm in. That would be Naja. All right, welcome. So this is, I'm sorry, there's no graphics with this PowerPoint presentation. So it's kind of you have to sort of focus on the ideas rather than the presentation, because the presentations are kind of, well, lacking somewhat. Anyway, so let's talk about it. Anyways, PowerPoint has dedicated that. Okay, yeah, whatever. So we
Sir,
are
could you
going.
let me in from my iPad?
All right. There you go. So I'll keep that there so I can see if anybody else comes in. All right, let's go. Introduction about Premier products. So we're using Premier products as an example so that we can learn by doing SQL. So that's why that's the only reason for Premier products here. In other examples, you might use something else. Uh, but at the moment we're using Premier products. So the idea here is Premier Products has lots of different data. We organize the data and into a way that will work efficiently on our computer systems with SQL. Now, we could spend many, many hours. You could take a whole course at college in how do you design databases. And usually that's actually what would happen. And I think if you go on with your software, I don't know about the hardware students, but I think the software students probably will do a course in database design. And so there's a lot of kind of rules associated with how we use our database, so that we have a lot of rules, referential integrity, this kind of thing. The idea being that we remove redundancies. The idea being that we have a database that works, that doesn't break down when we add data, delete data, etc. So I've used that term database. It's worth defining it. It contains categories of information. Categories relate to entities. So I use that term specifically because if you do database design, you'll talk about entity relationship modeling, possibly. Which is a good way of sort of sorting out, well, what are the things that we want to store data about? What is the data that we want to store? What are the relationships between the data? And from that, we can see how we're going to organize our data and what tables we're going to create and what keys we're going to use to relate those tables. So the categories, the word I just used was entities. Entities roughly translate into categories. So each of these would be an entity. An entity in the old way, obviously it's old way of talking about it, is something on which we store some data. So and we call them a category here. Sales rep, we store data on. We store data on customers, orders, and parts. The orders category is different than the others, because the others we're just storing some information about them, but the orders, I would call it a transactional category. That is, the order relates. If you have an order, it's going to have a relationship between a customer who bought some parts from our sales rep. So an order is sort of pulling things together into a unique transaction, and so I refer to that as a transactional category. And so I've also used this word already now, relationships. Relationships between the entities, or the categories as they're called here. So for example, a customer, every customer in this particular um, every customer that comes to this particular organization and makes an order is going to have that order handled by a sales rep. And so there's a relationship between the customer and the sales rep. And every order which is created in this organization will be for a customer. And I hope those make sense and it's obvious to you. So let's talk about this business. If you were a business analyst or a database analyst or a systems analyst, you would sit down and you would do this type of thing. You can't make a computer system for a company unless you take some time to understand the company and what is actually required. And so there's as I said, I use those terms. You could become a business analyst possibly, or a systems analyst, and you would do these things. So you'd sit down with the company and you'd find out about their business, and so you'd find out things like, well, Premier Products distributes appliances, housewares. That's kind of important because why is that important for our database? Because this is the kind of data that's going to be in the database. And maybe there's some specific things about appliances, housewares, and sporty goods that we need to know before we sort of organize those categories that we were talking about in the previous slide. At the moment, they've got a manual system. When we say a manual system, we mean they're writing things on paper. Oh, well, it might not be they're writing by hand. Maybe they're using Word or something like that. Probably manual, we mean that they're writing things on paper, though. That's kind of 40 years ago stuff. Nobody's really doing that anymore. But yeah, so they're finding that it's not working out for them, right? I mean, and it wouldn't. You'd lose information, information be destroyed. Information is hard to find. You got to go through paper. I mean, my goodness. So who does that nowadays? Nobody that I know. So the database management system will allow current accurate data with useful reports. So in other words, we're putting all of this data onto a computerized system. And so as fast as a computer can work, we can retrieve data, we can analyze, we can allow the computer to use the relationships between those data to produce reports that are useful to the management. Things that that management would normally do. We could say, okay, well, I know I've got all of these orders. I know that I've got all of these salesmen. What if I wanted to know how many orders did this salesman make during the month? How could I find that out? Or what was the total value of the sales that this salesman made during this month? Or how many washing machines did this salesman sell during this month? Those kind of things are kind of important to managers because maybe they have some kind of a compensation scheme which is based around that, or maybe they just want to help with their planning, right? Okay, this guy is selling lots of washing machines. Maybe we're seeing that this kind of washing machine, is selling well from them. Maybe there's some training that he can give other people or something. Yeah, very useful stuff for managers. Now, what I've just been talking about, those kind of things, they come to a manager's head. But how do you get that out of pieces of paper? Very hard. SQL to the rescue, because SQL allows you to do these things, which I've just alluded to, though I didn't use the term. SQL allows you to do what we call ad hoc queries. Ad hoc queries, and we use that term because ad hoc means that we haven't planned it in advance and sort of fixed it in stone in some kind of algorithm that's been drawn up. What an ad hoc query is going to be is somebody is just like that, just thinking, oh, I want to know how many of Westinghouse refrigerators of the 200-liter variety were sold during the month of August in 2018. Okay, so we don't have a standard report for that. Now, in the old days, they've had databases since the 1950s, really, electronic databases. But in the old days, if you wanted that report, you'd have to write out on paper somewhere saying exactly what you wanted in the report. Then you'd have to hand it to a programmer, and the programmer would spend a day writing this program to get this out of your computer system. Well, no longer do we need to do that because we have SQL, and it'll allow you as ad hoc queries. Somebody who understands SQL very well, who's a SQL programmer, or maybe you, because SQL is quite intuitive, could in 5 minutes come up with the answer. And actually, even managers, people that haven't been trained in in computing as their number one training. Maybe their first degree is in commerce. You know, they're an accountant or whatever. They can very quickly sort of understand the things that we're talking about here and write their own queries. Got a long story, a backstory on that. If you're interested, ask me sometime. What could possibly go wrong when somebody who's not an IT expert comes up with a computer system using SQL? And I got a nice story on that, but I'm not going to tell you about it now. I'll tell you about it later. Um, Required data for sales reps. Okay, so the required data. So I mentioned this idea of, well, they call them categories here, but I called them entities. So an entity or a category is something about which we store data. And so what data do we store? If you were going to design your database or create a database, this is the question you'd ask. Okay, well, I'm going to store data about sales rep. What data am I going to store? Well, I'm going to store each sales rep has a unique identifier sales rep number. That's kind of important, and I'm sure you've come up across this before, right? If you're going to have database systems, every individual that is unique must have a way of uniquely identifying them. So we don't use their name, and the reason for that is because it's possible that two people could have the same name. You could have two Mark Flodens, uh, potentially, I suppose. You know, there's no law against somebody. There's lots of Flodens in northern part of the United States, and there's lots of Flodens in Sweden because that's where the Flodens came from, right? But and it's quite possible that there's another Mark Floden out there, right? And we could be hired at the same time and work in the same company. Two Mark Flodens, what are we going to do, right? Okay, so what we do is we give this one this number. My work number here at the college is 600-57213. And so from point of view of the computer system, that's how they identify me. It's a unique identifier. We're always doing that. Um, so we got a unique identifier. We've got all the other stuff that we want to restore about them. Same for the customer, unique identifier, key. That's going to be a key field. The primary key, we call it, is going to be a unique identifier. Then all the other stuff that we want to identify about them. Now, there's a special one down here, right? Why does the customer have in the data that we want to store about them the sales rep number? Well, that's because of the business rules, right? Now, I was talking to you a minute ago about if you're going to make databases, you're going to need to sit down and look at the business and understand it. If it's your business, okay, maybe that's not a problem. But if it's somebody else's business, you're going to have to talk to people. You're really going to have to understand it. And the business rule here is that every customer, when they buy something, must use a sales rep. And so the sales rep is going to be, well, actually, it's not when they buy different things. It looks like when they become a customer, they're assigned a sales rep. And so everything they buy will go through that sales rep. It looks like because we're recording the sales rep as part of the details of the customer. So that's the way this has been designed by the business. That's kind of important, that we get those things right. So there's parts. So it looks like we sell spare parts for the fridges and stuff like that, I guess. And so each part, and you'll notice this if you ever get a chance to work in a parts store, every part has a unique identifier. Or if you become a petrol head or somebody who's interested in cars or motorcycles or something like that, you'll find you're always repairing them, and you'll be going and finding a part number, and that's how you identify the thing that you want, right? And so each separate part has a unique number, and that's how we can identify it. And then there's other things are a bit. Now we got something here, right? Number of units on hand. So in the parts, when regarding parts, we store information about how many that we have. Also, each item has a class, and we actually store in the parts table which warehouse that is stored in, and we have a price that's associated with it. So there's a lot of information there about parts, and actually that information tells us a lot about the way that they do their business. Okay, their business, they record for the parts, they record how many they have and where they are and what the price is, and they have a class for it. Very interesting. So what we're looking now, I mentioned earlier that when we look at the categories, we had 4 or 5 categories there, but one of the categories was different. That was the order category. And it's different because it was transactional. That is, it brought the data from the other categories or entities together in something that happened in a space and time, which would be a transaction. And so a transaction is when somebody, or in this system, is when somebody orders a part or a thing, all right? Okay, so actually, they're not spare parts. A part can be a full item like a microwave oven, right? So in this example, what we can see in this invoice, I guess we'd say, order, is we have some details that has a unique identifier for the order. It has the details of the customer. Isn't that interesting? So in the order, we've recorded the details of the customer. We also have the details of the sales rep. All right. So, and then we have the details that the customer has ordered. Now, the customer has ordered more than one thing. So that's all very interesting. So the order's got a lot of information in it, and that information has been drawn from multiple of the entities or categories. So we got information from customer, which we understood is a separate entity or category. Information from the sales rep, which is a separate entity or um, uh, category, they call them, and information about the item that's being sold, which we call the part. All right, so here's an example of a table. We're first time I think we use the word table in this lecture. I think table is used by relational databases. Here is an example of a table. I know that I'm pretty sure, I don't know, but I'm pretty sure you looking at that, you may have had some computer background or maybe not, but you looking at that table, it will be familiar to you. And it's like, how many tables have you seen in your life, right? Every textbook, while you're studying in primary school and high school, there was tables there, right? It's a natural way for us humans to organize data. However, it's not a very natural way for computers to organize data. And so this was the genius and the blessing, I guess you could say, for us in the business world that computing brought to us. Is for the first time we've got this way of representing data in a way that is useful for humans. Now, some of you might be sitting there saying, "Oh no, Mark, it looks just like an Excel spreadsheet." Yeah, it does. Yeah, okay, it looks like an Excel spreadsheet. An Excel spreadsheet, you can make a table, but it's not nearly as powerful as what we're doing here in Excel. And then some of you might say, "Oh, well, it looks just like Access." Yeah, well, Microsoft Access is actually kind of a copy of SQL, and you'll find embedded in Microsoft Access, you can use SQL commands. So SQL, relational databases, they gave us this, which is so awesome. The ability to store and represent data in tables in a transactional way, something much more than just what we're doing in Excel. All right, so in this table, what do we got? We must have a unique identifier. That's going to be the key field. That's rep num. So you'll see that though we don't have people with the same name, we could have people with the same name. We'd be able to identify them as separate because of a different rep number. We're storing a lot of stuff about them, unique details that would help us to identify them. That's all that stuff. And then here we're recording their commission. So that looks like it's going to be updated from time to time, and they have a commission rate. How much are they paid per item that they sell? So 3 sales reps in the table. So if we're looking at one of those sales rep, Valerie Kaiser, we'd find out all that information. I just looked at that with you. The next table that we're looking at here quickly is the customer table. And so what do we see there? You'll notice again that we have unique identifiers for each customer, which is their customer number. Then we have a whole lot of details that help us to identify that customer, that stuff there. That's customer name, street, city, state, and zip. And then the balance is here. We have recorded in the customer table how much they have purchased or owe us or whatever. I think it's how much they owe us. Then we have a credit limit, which is assigned to each customer. So somebody in the business office would assign that credit limit based on what risk they think that customer might be. And you'll notice that each customer has a single sales rep. So this sales rep uh, handles all the details for this customer, which is Al's appliance store. Now you'll notice that the same sales rep handles multiple customers. So we have a business rule there, which is uh, each customer is handled by one sales rep. Each sales rep can handle more than one customer. So we call that a one-to-many relationship. Just for when, if any of you get involved in designing databases, you'll talk about one-to-one and one-to-many relationships. Well, while we're on the topic of one-to-one relationship, for example, each customer, for every customer number, there's only one customer that is associated with that number. And so one-to-one relationships become part of the same table. If you have one-to-many relationships, then we use those to join tables together. And so that's the one-to-many relationship there between the representative and the customer table. They must be in separate tables. Otherwise, you would have a badly designed database, which we will look at in the last couple of slides of this presentation. All right, so each customer has a unique identifier number, and we got some other information about the customers, their credit limit, and their sales number. We talked about all of that. The part number, again, so we have a unique identifier for the part. I have some description of the part. Then we've got some transactional information that seems that's useful, because this, what I mean by that is it's going to be updated every time you you bring in new stuff or you sell something, you'll update these values here. And the price could probably stay the same most of the time. And there's that. Orders table. Now, so what is cool about the orders table? The orders table, I referred to it before as a transactional table. So what you'll notice about the order table is that each order has a unique number, just like in the other tables. Every record must have a unique number. We see the other things are not unique. But what's interesting is it seems that there's a relationship between an order and a customer. Now, a order has a single customer, so that's a one. Okay, it's actually a one-to-many relationship. Each order can only have one customer, but each customer can have more than one order. And I see that because the same customer here shows up for two orders. So that's, and also here, right? Customer 608 has got a couple orders. So that one-to-many relationship, that's important in when we're designing our tables. 7 orders are listed by order number, and each order number is unique. The date may not be, and likewise, the customer may not be, but the customer, the information from the customer number is used to make a link between the order table and the customer table. And we call that a foreign key. So if I just go back on that, customer number is a foreign key in the order table because the customer number is used to link back to the customer table so that we can get information about that customer. All right, so the order line table, the idea here is that when a person makes an order, the order is about something. And the relationship is not one-to-one. It's a one-to-many relationship. That is, on a single order, you can have more than one part. All right, each part in a order is with a single order. Of course, a part could be in many orders, but in terms of the transaction that we have for that order, you may have many different parts, and each of those different parts in an order, we can put them in a separate order line. So for example, here we have the same order 610, and there's more than one part is assigned to that order. We got 10 minutes left. My gosh, this is going fast, right? And so there is the multiple parts on the same order. And so because of that, we had to split it out and make a new table. Now, there's some information about those things. Now, that's what the last couple of slides here are about. What if we decided that somehow for each order, we allowed to have multiple parts on the same order? When you see that happening here, right? Order 610, what we've done is we've recorded 2 items. Yeah, it kind of makes sense to us as humans. It would work really, really badly in a relational database because how do we track this? We don't have a unique way for getting this information about this part number back to a unique order, because are we talking about this part number or that part number when we're talking about that order? So that is why we actually split it out and have a special table just for the order line for each part that's been ordered. And so that's what this slide is about. It's going to be really bad if you don't do that. Now, I mentioned in this lecture this analysis that we have of one-to-one and one-to-many. That will help you overcome this problem of the alternative order table. We won't be doing any of that, right? We won't have any tables where we have an order which has multiple lines in it and put that all in one table. No, no, no. So what we'll do instead is we'll say for each order, we're going to have everything will just be one item. Okay. And so how we're going to have to do that is we're going to split that out to an order line. Okay. So the order line table makes things a lot better. It actually obeys the rules or the laws of relational databases and SQL. All right, so we only got 10 minutes left. I'm sorry, I didn't realize it's going to take so long. So what I'm going to do is I'm going to go and let's look at another item, which is the actual exercise that we're going to do today. So I'm going to share that. I'll get you started on it, and then you see how you go. All right. So this is the exercise that we have to do, and I will sort of get you started on this. So this is what we have to do, right? So here are the tables. So we're talking about relational databases. Relational databases, all of the data is going to be stored in tables. And I mentioned to you why that is, because humans can look at tables, you understand it. And computers, I have other ways of understanding things. They don't actually need tables to understand it, but we do. And so it's nice that a computer can produce a reports with tables, and we can use tables. Now, let's have a look at we got 10 questions. I'll do a couple with you maybe, and then we can sort of let you look at it. So all you need to do, I'm going to answer with SQL. You don't need to answer with SQL because I haven't taught you SQL yet, and we haven't had time in this lecture. All you have to do is you have to just answer it. So maybe you could look at this and you could think, what would be the answer? List the name of all the customers who have a credit limit of 7,500 or less. Now, if I asked you and you looked at all these tables, where do you think you would look? I'm guessing that you wouldn't look in the rep table, you wouldn't look in the orders table, the order line table, or the part table, but you might look in the customer table, and sure enough, in the customer table, you see that there is a field called credit limit, and scanning through the credit limit field, you can see, well, this guy's got a credit limit of 7,500, that one 10,000, 75, oh, this one 5,000. That is less than 7,500. So there's one. So this customer has a credit limit of less than 7,500. And there's another one, Leo Sport. Okay, so there's two. So you could just say the customer's names and you could just write them down. That would be Ferguson's. They want the names, right? They want, oh, sorry, it's not Ferguson's. It's the Everything Shop and Leo's Sport and Appliances. So you could say that, you could just say that, the Everything Shop. Sorry about my typing. I'm kind of in a hurry because we only got a few minutes left, and I got a chat question. Select customer. Very good. Somebody knows SQL. Yes, very good. So the Everything Shop and the other one, okay, so what you would do is you would say, actually, I would just say select start. Now, you almost have that right, Naja. What you missed out was the from. So yeah, if you wanted to do it in SQL, you would say select. I would just do select star from customer where credit limit. Yeah, so very important with the SQL is that you have from in the statement where is less than 7,500. So, but very good start there. Thank you. We must end our select statement with a semicolon. So almost. So that would give you all the customers that have, you could have done customer name though. Actually, it's not wrong to say customer name because that's all they asked for. So very good. Yes. So that's how we do it. And that would give you the results of everything shop and that other one. All right, list the order numbers from orders placed by customer 608. Ooh, tricky. That would give us all the customer details. We only so query would be select. Yeah, it would be. I like to get all the customer details because then I can check it with the other thing that I'm working on. But you're right. It would be all we need is that one from. Now this one is just for order numbers that were placed by customer 608 on a certain date. So we would go and look in our order table and see, okay, on there, the order table does have the date and it does have the customer number. What does it want? All it wants is the order numbers. So again, if you wanted to be sort of picky on that and just get the things that it asked for, just the order number, you would just say select order number from orders where customer number, customer num, where customer num is equal to 608. I'm using quotes because we wouldn't store this as a number. You'd store it as a text. And so there's two criteria right there, right? There's two criteria and order date. The criteria are after the where. And so an order date equal, equal 10. Now, the date might not work depending because there's more than one way of storing date in SQL. But yeah, it would be something like that. And if you went and looked at this, all right, so 608 on that day. So that should give you the answer of 617 and 623. So that should give those answers. You get the idea? So you don't need to write the SQL query. If you think you can do it, go for it. But you don't need to. List the part number, part description, on-hand value for each part in item class SG. So it's multiplying. So here you have to do a calculation. On-hand value is a result of multiplying the number of units by the held in price. So everything with SG, so you look in the part table, only the things with SG is a selector there. So we've got two parts that are SG. We would take the amount on hand and multiply it by the price. So treadmill is in SG, 9 times 1390, whatever that is. I guess it's going to be about 1,500, no, not that much, no, 1,200, 12,000 and something. Let's just have a look. 9 times 1390.